Probabilities and Data Displays, the third probability assignment in our probability unit. Let's dive in. As we do, make sure that you have your Desmos calculator and your fraction reducer. We'll need both of those throughout this unit. And we start with a pie chart, otherwise known as a circle, split into what looks like a peace sign and a half, or it's like, hey, it's like someone wearing a mask, or Bane. Hopefully I don't have any problems with copyright issues for saying that, but Batman villain, very famous. Find the missing degree measure in the pie chart. So to do this, we need to remember how many degrees are in a whole circle. If you ever forget this, I always recommend thinking about skateboarding, snowboarding, something like that, where if I start in a spot and I go all the way around, I have just done a 360. You can also do halfway around, which is a 180, and then do another 180, and that is 360. You can also remember the 90 degree right angle. For those, you're turned all the way around, also 360. In any event, it's 360. So we're going to start with that. So in Desmos, type in 360. And we know if the whole thing has to add to that, then we're going to subtract all three numbers here. It's very important you do all three to get our fourth number. And as always, use your numbers, not mine. You're definitely going to have new numbers every single one of these problems than what you see on my screen. And if you use my numbers on your problem, you're going to have to redo it because you're going to get it wrong. Number 2 is a similar problem, but it tells you that the red sector, this X, is 1/5 of the entire pie chart, the entire 360 degrees. So right off the bat, start by doing whatever fraction you have. So if you have a third, type in a third. Half, type in a half. Sixth, type in a sixth. And remember to use the slash next to your right shift key times your total number of degrees. That will give you X. And then from there, to get Y, we now have the three angles again, just like we had up here. So I'm just going to go up here. I'm going to replace these three angles with my three angles. So I do 360 minus 153 minus 70, and then this is the one that students often forget about. Also, do minus what you got for X. So I got 72, which makes sense. This is an angle that is acute, less than 90, so then you should get a number that's less than 90. If you don't subtract that last angle, you're going to get an obtuse angle. It's not going to make sense. You're going to get it wrong and have to redo it. So remember to subtract all three angles on 1 and 2. Number 3 is similar. We have a circle again, but you'll notice that we only have half of it up here that has X and Y. This bottom half is blank, which means this half of the circle we can just ignore. And instead of 360, later we could focus on 180. But first, we have to use our fraction, just like we did before. 1/18 of the entire, not the half of it, the entire pie chart. So I still leave 360 in there as I do 1/18 times 360. And I get 20, which makes sense. This is just a small sliver of an angle right there. Then I could come up here. I guess if you wanted to use 360 to keep it consistent, you can just start by doing minus 180, so subtracting that half. Or you can start with 180, your call. And then subtract our other two angles. So 95, and then also don't forget about 20, or whatever you got for X. 65 degrees looks once again just about perfect for that angle. So I know that should be right. And it is. Number 4 is the first word problem where we're going to need to use our fraction reducer, and it talks about trees. A tree farm sold Douglas fir, very popular up here in the Pacific Northwest where I live and teach, spruce, and noble fir trees each year. A random sampling of 200 purchases from the previous year was used to plan for the following year's crop. The results are recorded in the pie chart below. Write all probabilities in simplified form. So like I said last assignment, these are very applicable problems. You could think about having a Christmas tree farm. Heck, maybe your family does. And you have to figure out how many of each type to plant if you have multiple types the following year. So you go on your sales and you figure out what are the most popular trees, and those are the kinds you want to plant more of the following year. I think about that in terms of something that's very near and dear to my heart, which is pizza. If we're ordering pizzas for a big group of people, I don't want to order too many kinds that people don't like. which is why I personally default to lots of cheese, lots of pepperoni, a little bit of Hawaiian, and then maybe one pizza or two pizzas that are like veggie or supreme or something like that. Because to be real, unless you like have a dairy allergy and then you have to have like a cheeseless pizza, even the vegetarians will eat cheese, and most people will eat pepperoni if they eat meat. So that'll take care of most. It makes me so sad, and I have so many memories of showing up at pizza parties, and there's like 5 veggie pizzas left over at the end that even hungry teenagers won't touch. It's very important. It's a very applicable problem. Near and dear to my heart. End of pizza rant. Out of 200, you see 50 Douglas fir, 70 spruce, and 80 noble. P spruce. Remember what P means. That means probability. We have 200 total trees, and I have 70 spruce. So I'm going to go over to my calculator here. 200 will be on the bottom of your fraction, just like it's going to go on the bottom of mine. And on top, make sure to use your number that matches spruce right here. You hit calculate, and I get 7 out of 20. So I put that here. Then I do the same thing with my noble fir on bottom. I've got 80 noble firs. See? 80 noble firs. So that's 2/5. And then Douglas fir is the remaining 50. So I do 50 out of 200. And that gives me a 1/4. So finally it says there are 2,000 purchases from the tree farm each year. About blank spruce trees are purchased each year. So look at your spruce fraction. To me that's 7/20. Go back to Desmos and type that in. I type in 7/20. Whichever fraction matches my spruce fraction, because we care about spruce trees. And then I'm going to multiply that, just like I did before when I had my last assignment for waves or baskets or seals that I tagged. Figure out how many on average, theoretically, should I have in the future from spruce trees. 700. So I type 700. These are incredibly applicable problems. Like I said at the beginning of the unit, this is very nice to know in general in life, whether you have a tree farm or not. All right, number 5. Now we're talking. We're going to food. For some reason, this cafeteria does not have pizza, but I'll tell you what they do have at this school cafeteria. You got tacos. All right. You got hamburgers, a staple. You got spaghetti. I remember the years of ordering buttered noodles because I didn't like spaghetti sauce. But look at the middle here. Out is pizza, and in is cafeteria sushi. What the all-time hell. I can't even fathom what that would mean or would be like, but I wouldn't go within 1,000 miles of that sushi if I could help it, especially if it's like New Mexico where I grew up. I don't want to think about sushi flown in like days and then put it in a cafeteria. Ugh. Either way, we need to start by figuring out how many total students were there. And for that, let's add up all of our numbers. So I add up 15, 20, 30, 10. I have a total of 75 students. So for you, add up all of your numbers to figure out how many you have. And then you could go over to your calculator, and just like we had 200 for the trees, put whatever number you just got on bottom. So I got 75, I put 75 on bottom. And then we just follow our words like we did with the categories of trees. So tacos, I have 15. I put 15 tacos on top. That is going to give me a 5th. And then the dreaded sushi. Somehow 20 brave souls were probably going home with food poisoning. They tried sushi, 4 out of 15. Hamburgers. Every time I think about cafeterias, I think about chicken nuggets, but I also think about hamburgers. Very common in my memory from cafeteria food. And spaghetti. Also a staple. 10 out of 75 is 2 out of 15. All right, then we have a problem just like the one we had where we had to use Desmos last time. We're going to do that again. It says there are 825 students in the school, so I'm going to do 825 times the hamburger fraction. I got 2/5. 2/5. Notice, because multiplication is commutative, I can do it in any order, whether I do it like this or like the tree. I wanted to put the fraction first, then multiply it. You'll get the right answer either way. You should get a whole number, like I get 330. And there it is. Perfection. Perfection, perfection. Number 6. The histogram below shows the number of visitors in each age range that visited Children's Museum during a time period of 1 hour. Notice it's not the Children's Museum, a Children's Museum, it's just visited Children's Museum. Must be the only one in town, I guess. All right, you can see from this graph, it makes sense that the ages 0 to 10 have by far the most people in that museum for the hour. 200 kids in a children's museum, makes sense. Then you have 20 people ages 10 to 20, 60 people ages 20 to 30. A lot of parents in this range, 120, 30 to 40. And then we got maybe some grandparents or some older people relative to the kids who are there. We got 10, 40 to 50, and 20, 50 to 60. Which age represented the largest group? Well, we could see it is, as I said, by far kids, or ages 0 to 10. It's going to be true for you. During that hour, approximately blank visitors came to the Children's Museum. So just like we did up here for the food, we want to add up all of the numbers in each age range for the whole hour. So I'm going to do 200 plus 20 plus 60 plus 120 plus 10 plus 20. And if I've added that correctly, it's 430. Should get a number in that general range. It says find the probability that the next person to visit the Children's Museum is between 0 and 10. So I go over to my calculator, and just like I had the tree number and then I had the food number, now I'm having my museum number of 450 on bottom. And then I match up top like I did before. 0 to 10 is 200. So that reduces to 20 over 43. And then 40 to 50, that's the smallest group, just 10. So that will turn into 1 over 43. And then finally, if 1,720 people visit the Children's Museum one day, blank are likely to be in the 10 to 20 age bracket. So here's what we do. Let's just click over here automatically. Let's do what we did before, which is figure out our 10 to 20 fraction. Well, in 10 to 20, there are 20. So 20 out of 430. I don't even have to reduce this since I'm going to multiply it. Times how many total people? 1,720. So 1,720 that day. And 80 of them on average, according to this, will be from that age range. And you'll know that you've done it right because you will get a whole number. Lots of times when people make mistakes on this one, they get a decimal, and I say, hey, what is that decimal supposed to mean as a person? You're only whole people entering museums. Come on. Number 7. Let's end this talking about kitties. Kitties, kitties, kitties. Creepy. All right. Each one of these boxes represents a kitten. Cute little kitten. Weighing a certain amount of pounds. The smallest kitten, there are 2 of them here, weighing 1.5 pounds. And the largest kitten, there's one 4.3 pounder here. And a lot of 2s and 3s. So we're simply going to look at this data, and we're going to use it to answer these questions. Number 1, there are blank kittens at the shelter. Well, let's just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I believe all of you, that's 1 for free, will get 10 kittens in the shelter. How many of them weigh between 1 and 2 pounds? This is where you need to count because you're going to probably get a different number than me. I've got 2 that are 1.5 and none other that have a 1 in front. That's how we know they're between 1 and 2 pounds. They're going to be 1 point something. So for me, it's 2. Count how many for yours. Now 2 and 3. How many of mine are 2 point something? Well, I've got 1, 2, 3, 4. And how many are between 3 and 4 pounds? 1, 2, 3. Now notice, 2 plus 4 plus 3 does not equal 10. And a lot of times people will screw up because they'll change this last number to make it add to 10. That would be ignoring my favorite Pokemon of all time. Shout out, Snorlax up here. Baby Snorlax weighing that 4.3 pounds. He's in his own separate category. That's not included here. He's too big for this problem. So don't worry. It's not going to add to 10, but that's by design. It is just fine. and I love to rhyme, all in good time. Off rhyme. There it is, 100% Hundo Benji. Get it done. Get it done. A little over 15 minutes. Lots of stuff here. Peace out. Bane out to you. Bane of my existence. Puns for days. Have a wonderful one yourself, and until next time, it's been an honor and a pleasure teaching you away from class. Dylan is out.